So yesterday we talked about transformations, and specifically we talked about transformations from the parent graph y equals x. Remember, the parent graph y equals x is the parent graph of our linear functions, and y equals x has a y-intercept of 0, 0 and a slope of 1. So remember how we can change an equation which changes the graph. You can vertically translate it, so if a number is added, it's going to move it up. If it's subtracted, it's going to move it down. You can reflect it, which means a negative is going to be on the outside, which makes sense. For example, if you have a negative, it's going to make the slope negative, which is going to make it go downhill. All right, we can have a vertical stretch or a vertical shrink. A vertical stretch just means that the slope is bigger than 1 and it would be steeper. That's why it's a vertical stretch. And then the slope is less than 1, so it's a vertical shrink. I also want to talk about horizontal translation. The graph can be moved left or right, and it's with the x, but it's the opposite of what you think. If I have in parentheses x minus 3, it's going to move right 3. If I have in parentheses x plus 3, it's going to move left 3. So if it's included with the x, think about it. That's why it's going to move left or right. So I want to go to the bottom here, and let's read these directions. It says, if I give you the function f of x equals 3x. Okay, first of all, if you don't like that, you could write y equals 3x. Describe how the graph of f changed to the graph of g. Okay, so I know this may look complicated, but all this is saying is, all right, if I take f and subtract 5. So all that's saying is, oh, if I take my line and if I subtract 5, doesn't that mean it's moved down 5? It's vertically translated down 5. All right, what does this mean? All right, it looks so much more complicated than it is. Isn't it just saying that you're going to take this and put a negative on the outside? So a negative on the outside means it's reflected. All right, well, think about this original function. Doesn't this have a slope of 3? So it's uphill. Well, now a negative on the outside, slope of negative 3, so it's downhill, it's reflected. Okay, let's go to the back side of this. So still using that same function, I'm not saying that's the parent graph, but this is the function that I'm working with, y equals 3x. Describe how it changed, all right? So this is just saying take 6 times that function. Well, doesn't that mean that it's going to be a really steep line? Sure, if I take 6 times 3x, that's 18x. That means that it's going to have a slope of 18, so it's a vertical stretch, steeper. All right, now what does this mean? This just means that this graph is going to be moved, the x-intercept's going to change, and it's going to be translated right. Okay, right 9. With the minus 9, it's the opposite. Okay, example 5, what does this mean? All right, all it's meaning is saying I'm taking 1/2 of this function, which just means I'm making it a smaller slope. My slope is 1/2 times 3 is 3/2. So it makes it flatter. It's a vertical shrink. Okay, let's take a look at example 6. We got a couple of changes going on here. We know that the 7 means that my slope is going to be multiplied 7 times. So it's going to be a vertical stretch. It's going to be steeper. And my x-intercept's going to change. It's going to be translated left 3. So it'll now be at negative 3, 0. So now let's take a look at this and let's look at all of the changes, lots of changes. We got every possible change there is. A negative means that this is going to reflect. So won't it be downhill now? Decreasing. All right. The 2 means that my slope is now going to be 6x. So it's going to be steeper, or the correct word is vertically stretched. All right. The plus 4 means that it's going to be translated or moved left 4. So, and then the plus 8 means it's going to be moved up 8. Okay, so now use some notebook paper or note paper, and let's do the same thing here. See if we can figure out the changes. Okay, so if I give you the function 4x, describe the transformation from f to g. So basically all this is just saying is, if you don't like 4x, you could say y equals 4x. You know what that looks like, right? Slope of 4, y-intercept of 0, 0. So now this is just a way to say I'm taking this function and subtracting 2. Well, what does subtracting 2 mean? We know that that means it's going to be translated down 2. So it's going to be moved down 2. So my y-intercept is going to be 0, negative 2. All right, what does a 3 multiplying in front mean? All right, well, if this is 3 times 4, that would be 12. So I know that it's going to be steeper, or the correct word is going to be vertically stretched. The slope is going to make it a lot bigger. All right, so what does a negative out front mean? Well, a negative out front, wouldn't that mean a negative 4x? So doesn't that mean it's going downhill or decreasing? And the word for that is reflected. All right, what does a 1/2 out in front mean? Well, if I take 1/2 of 4, isn't that now 2x? So doesn't that mean from here to here, my slope, it got flatter, it's got smaller, so it would be a vertical shrink. All right, so this graph has a y-intercept of 0, 0. This would mean that it would be translated left 5. All right, let's look at this last one. Lots of things going on here. What does the negative do to the graph? It makes it go downhill. It's a reflection. What does the 6 do? Well, that makes the slope steeper, so it is a vertical stretch by 6. The -2 means that the graph is translated right 2. And the up 3 means it is vertically translated up 3. So don't let the f of x and g of x, do you guys understand that f of x is just a way to say y equals 4x, and the g of x is just a way to say, oh, I'm changing that by changing the equation. So f of x is like your old, g of x is like your new, or your transformed. Okay, so now let's take a look at some questions that were similar to the book. So if I gave you f of x and I gave you g of x, describe how g of x changed. All right, so first of all, I graphed, so this is like something from the book that you had to do. If I graphed this, wouldn't this be in black, a line with a y-intercept of 0, negative 1, and a slope of 1, up 1, right 1? So now this is just saying I want you to take the old one and take the negative of it, which a negative means it's reflected. So now, instead of my line being a slope of 1, it's now a slope of negative 1. So y-intercept of 0, negative 1, up 1, left 1. So do you see they're like mirror images, reflections? Okay, next one. If I have the line y equals 3x, which is what I have in black, so my y-intercept is 0, 0, slope is 3, up 3, right 1. Now, my new function, I want to take that and move it up 2. So doesn't it just mean that now I have a line with a y-intercept of 0, 2, and a slope of 3? All right, the next one. If I have f of x equals 1/2 x plus 3, and the new function is my old one, and I subtract 3. Okay, so look at my old one. Y-intercept 0, 3, right? So my slope, oops, I meant to make that a negative. Sorry, that should have been a negative 1/2. All right, so my slope is a negative 1/2. Now, if I'm taking my old function and moving it down 3, if I'm moving it down 3, isn't it just now my y-intercept is 0, 0, and a slope of 1/2? So I think sometimes the notation on this can be confusing, but you just have to look at it as if you're going from the old to the new. So you take your old function and make the transformations to get a new function.